My name's Campbell. Can you guys hear me okay? And I work at Lucidworks. I'm a consultant for Lucidworks. And I've been in search for 21 years. So that's a long time. I've done a variety of things in search. I've done a distributed web crawler at Grub. I worked at LookSmart. I worked at Splunk. I was the evangelist at Splunk. I was the founder at Loggly, one of the founders at Loggly. So I've been around for a while, and I've kind of meandered in and out of search, but I've always come back to it. And so here I am again, back in search at Lucidworks. So I call myself the futurist because nobody really knows what I do at Lucidworks, but I think about stuff and I build things. What do what?
One day you will.
One day you will. So we're gonna talk about awareness today. Awareness is sort of a strange topic, and so I'll attempt to do my best at explaining it. Awareness is not something you can exactly put your finger on. Sometimes when you have different languages like Sanskrit and Pali, you'll have a word which will not have a direct translation to English or to other words in other languages. So a lot of times you have to say a lot of words, you have to get the context of something. And so awareness, there are two sort of general approaches in the world. Awareness from the Eastern perspective, from the Eastern sort of faculty of mind, comes from the word smrti, which is Sanskrit, and its root word is smara, and smara means to think on or about or upon, or call to mind. To call something to mind, to think about it, to be aware of it. Philosophical methods that are related to awareness include, in Eastern faculties of mind, include things like conviction, energy, mindfulness, stillness, and wisdom. And I've put the Pali translations of those words here. Western faculties of mind work a little bit different, and that's obviously the framework that I've been existing in for the last 50 some odd years. And that started all around about 550 BCE. So, 2,500 years ago. And this guy named Zeno of Ella, and this is Zeno, he hung out with some philosophers back in the day, and he came up with this idea of having a rational argument, to be able to come to reason about something of fact. And what this ended up doing essentially to us was it split our philosophy, which was the study of essentially everything, mind, body, sciences, things like that, the world. It split it into sciences, and then philosophy, medicine, psychology, things like that, in the Western regions, I should say. And those methods provide some semblance of the same types of awareness faculties as consistency, rationality, focus, and pragmatism is what we operate on in the West now, especially in the United States. So back around that time, Plato came up with this sort of theory of forms. So he said, well, there's a physical world, and from that emerges the mental world, because we're all in the physical world. We have these minds that exist in the physical world. And from that emerges understanding of the mathematical worlds, so the mathematics of the universe, which then gave rise to the physical world. So he was trying to sort of make it a circular arrangement with these ideas, these metaphors of his way of trying to explain how things worked, especially around mind. And you still ended up with a bunch of mysteriousness in between these, like how does it emerge out of this, and how does it give rise to the other. So the way that I look at this is magnets. Like, we all know what magnets are, but actually none of us know how magnets work. So we can describe what they do very well, and so I put it as they're a common mystery best viewed in terms of their practical use and explanations. So we can explain how they work. We use them in computers and cameras, and there's probably a magnet in here. So we use them all the time, but there's a lot of mystery to still how some of magnets work, the basics behind magnets and the rest of the world. But we tend to ignore those. We don't really talk about them a lot because we can't go and be rational about talking about it. We have to be irrational when we talk about them, and so we avoid doing that because we like to have explanations that make sense. So this sort of feathers into, this is pure
philosophy, right? And I'm not a philosopher, at least I hope I'm not. But I'd be okay if I was, I guess. But like the whole philosophical argument that kind of came out of all of this before we got where we're at today was this sort of idea of dualism and monism. And I'm going to explain this real quick. I'm not going to stay on this slide very long, I hope. But basically, duality or dualism is the idea that mind, your mind, what you think with, is of a separate matter or material or something that's distinctly different from the matter that we see around us, like this ground. So your mind and this ground are different things. And they can't be representative of one or the other. You can't like dissolve mind down and get matter. You can't dissolve matter down and get mind. They're completely separate. And that is versus monism. So this is sort of a West thinking. This is sort of East thinking, if you will. And there are some modern versions of this. So monism, for example, has physicalism, which is physical matter gives rise to mental matter. And then you have the opposite in idealism and stuff. So this is sort of the way I look at it. This is Yoda. He's being printed on a 3D printer. So he's literally we're literally printing a 3D printer, printing an enlightened being, I guess is what you could call that, right? And so this is Yoda's quote. Many of the truths we cling to depend on our point of view. So it just depends on your point of view whether or not you believe that matter and mind are separate or different. But we don't really have any way to prove that, so we just have to sort of move on from that and realize that it's the way that it is, and you have your opinion on it, and that's about all we can do. It's just an opinion, so we can't make a rational argument about it yet. So awareness is the foundation for the mind's layers. If you look at Yoda, he's got layers. So of the mind's layers, it's an attribute we use to achieve unsupervised self-reference. I'm going to read these slides, by the way. I don't have a lot of these, but it helps me sort of focus my awareness a little bit, if you will. The intelligence that we have, the smarts that we have, provide related rational sense of past events. So like log files, for example. I've done logs for a long time. And logs provide a lot of intelligence to your systems if you can understand them. And you can understand what's happened in the past as it is related to the present. Thinking on events and happenings here in mind and in the now is awareness. Thinking about what you're doing right now. Sitting in here listening to me prattle on about awareness, for example. The term chit, which is Sanskrit, it means awareness of other senses. So awareness of your smell sense, awareness of your vision sense. And in general, mindfulness of being aware. So you can be aware of being aware. That's consciousness. So this term also sort of has this inverse or this reverse idea or not idea, which is prajna or pragya, which is an awareness level that's higher or beyond what you're currently aware of. So I'm going to talk about this here again in a minute. So if we were going to build a self-aware machine, these are basically our choices. We can have a rational scientific argument about it, and we can try to figure out a test, to formulate a test if we can build a self-aware machine. It's going to be really hard to find that test because we have to prove it wrong. So we have to find a test that we can try to falsify, that we can build an experiment to falsify. We could take an alternate methodology, which is thinking that everything is mind, that some people think that, or everything's a hologram. But then we're already done, because we're already those self-aware machines. That would mean that we're already here now. I think Steve said something like that earlier, right? So we're already done with this. So we could have the talk over. Or we could take a cross-disciplinary approach and try to figure out how to look for an interesting solution to the problem that we have at hand. And I'm going to make that a personal problem that I have at hand, which I'm going to talk about here in a second. So if we look at like knowledge, you essentially start out with a problem space, and then you end up with, if you're doing scientific approach, and science disciplines is the topic here, you end up with this little circle of things you know about what you're looking at. And then eventually what happens is a whole bunch of stuff springs up. If it's successful and it makes money, a whole bunch of stuff springs up. And then it ends up, things end up kind of merging, coming together. What's happening here today in this conference is
a whole bunch of disciplines are coming together. There are people who study mind, there are people who study AI, there are people who study search, people who study robotics, the body. They're all coming together. We're all sort of coming together and starting to talk about this stuff. And at some point, you cross over and you start overlapping, and then there's this synthesis of discipline at some point. All right, so that's it for the philosophy. We're not going to talk about it anymore. That's it. So you made it through it. I made it through it. So this is the way I think about consciousness. So I think about it. I don't actually visualize, but this is the way that I sort of imagine or conceive consciousness. And I just sort of think of like this is the visual layer, and this is the audio layer, and this is my touch and taste and smell, etc. And if we were to like tease out one of these, our body consciousness, like our awareness of our body itself, like our sense of touch, for example, or hunger, you can kind of imagine it as a layer. It's not really a layer. I mean, if you were to train a neural network model, you'd have lots of different separate layers, but we're just teasing out the body consciousness layer here just so I can kind of illustrate that stuff is going on that may be happening to you in here. You're balancing in your seat, maybe your ass hurts, maybe you're hungry, maybe you're bored, right? Things like that are occurring to you, some emotional responses coming in from your body. In the Buddhist view of this, which again is an Eastern thought philosophy, you have a guy named Baku Bodhi, who he's still around. He's a Buddhist monk. He teaches, and he took Buddha's basic like diagram of how consciousness might work. You know, Buddhists and Hindus and Jains have studied consciousness for years and years. And if you want to find this, you can just actually search Google for nose consciousness diagram. I know that's a little weird, but you do have a nose consciousness. And this is sort of how it works, is you have a tongue, for example, and then you have something to taste on the tongue, and then a signal is sent, and then a tongue consciousness, whatever that is, that's that layer that I showed just a second ago, becomes aware of that taste occurring. And you have contact with it. That's what sort of the general sense of, like, you come into contact with something that tastes like coffee. And then you get some feeling about it. You know, this coffee's cold. And then you get a perception about it. I'm talking about coffee, my coffee being cold, right? And then you have some thoughts about it. So this is just a general diagram. This is not truth. This is not something I'm saying somebody went and dissected the human brain and said this is how it works. This is just one way to represent it with a functional model. So in the case of this owl, he's using his vision as well as his body consciousness, so his visual consciousness and his body consciousness, to keep his head straight. And if you've seen chickens do this, you can grab a chicken and move a chicken around. He does that chicken head thing. Has anybody ever seen that? Where you need to move a chicken around and his head just, it's like a steady cam. It's like a Ronin, which is out in the hall, as a matter of fact. To hold a camera steady, you basically do the same thing. But here's the owl doing it. But he's mixing his consciousness layers to do that. Your eyes. Everybody probably knows your right hand is controlled by your left brain, and your left hand is controlled by your right brain. What about your left eye? Anybody? What's that? What is your left eye controlled and sent to? It's actually sent to both brain halves. So this is how it works. So everything above your gaze is split up. So everything on one side of one eye, and this is the right eye, and this is the left eye, so everything on these sides of the eyes gets routed to the left hemisphere, and everything on the left side of the eyes, these regions in the eyes, the actual sensors in the eyes, gets routed to the right brain. And stuff that's below horizon is routed differently than the stuff above horizon. So your brain is already sort of busting up these processes into different layers, the layers of visual consciousness to handle this. Whenever you come into contact with something, you see something, this is sort of how it works, is that you have an eye, it comes into contact with the object, and then your eye consciousness or your visual consciousness kicks on, and it may do things like visualize Groucho Marx. Does this seem reasonable to everyone? Right? This seems like this is something that seems just kind of obvious. You almost also might visualize your own cat. So if you're over at somebody's house and you see a cat, then you might visualize your own cat. So our eye consciousness or our visual consciousness consumes about 34 gigabytes of data a day. That's a lot of data. So we're consuming, like, you know, I see you guys in 8K widescreen, right? That's a lot of data. And our iconic memories, that's our visual memories, are store and recall imagery. So it's a consciousness layer that allows you to recall imagery, if you're capable of doing that, and then replay it later. Creative visualization consciousness is very similar, but it's just creating the imagery for you to view as opposed to recalling something that you saw before. So you can synthesize images. Some people can do that. But there are extremes of this. So like if we were to try to say, well, we don't really understand how visual consciousness works because it's so complicated and we know it's a neural network, and well, we don't understand some parts of how neural networks work, and we probably don't understand about how some of our brain works. So why don't we draw the edges of this? And we do. We have some data about this. So there are people like myself who have a condition called aphantasia, which literally means lacking the ability to consciously perceive a visualization in your mind. So if you're capable of creating a visualization and you're consciously aware of seeing it, having that awareness of seeing it, then you don't have aphantasia. And if you can't call it to mind, then you have aphantasia and you can't see it. Agnosia, which is usually due to some sort of trauma to the mind, causes you to have the lack of ability to understand what an object is. So if you picked this up, you might be able to say, well, this is rough and it's black, and well, I don't know what it is. That's what you would do with agnosia. In the case of post-traumatic stress disorder, PTSD patients report being able to relive a traumatic event as if they are there immersively. They're rehearing it, re-feeling, re-smelling, re-seeing everything that happened to them without any control of that. They have no conscious control of the recall. That's why it's traumatic and why trauma caused it. The theory of the bicameral mind includes the idea that over time that we have stopped having audio hallucinations. In the population in general has stopped having audio hallucinations that we consider or attribute to gods, leaders, things like that. It seems to be on the recession. And this is from the origins of consciousness and the theory of the bicameral mind, if you're interested in learning more about it. Back in 1504, they had a theory about how you could possibly see with your mind. And just so I can get a sample, how many people in here can visualize a taxi? Consciously see a taxi. Stick your hands way up in the air so I can see, just so everybody can see. Consciously visualize a taxi. So you're conscious of seeing the taxi right now. That's what that means. So for the people that didn't raise their hands, think about that. So, well, they thought that that's where you did it. So they had taken brains apart, and then they knew there were all these folds in the brains, and they thought, well, okay, so, and used to, they didn't think the brain was actually very important. They just thought it was some sort of organ. They wasn't sure what they did to it. They thought that you had mind matter. Again, remember dualism. They thought mind matter and regular matter were different, and they thought it just sort of got stored up here in your brain somehow, and when you died, it left. That's what they thought. And they thought that that mind matter projected what you see in your mind in this spot right here, which they called phantasia. Only 150 years later, Descartes said, well, it's the pineal gland. That's where you visualize, is in the pineal gland. So there's something projecting light in the mind, inside your head, on the pineal gland, and then that's the sensor for it, so that you can see. And it's the thing that's creating those images, whatever that mind matter is, that strange stuff in there. Not too terribly much longer, there was a theory floated by Johann Zahn called emission theory, which is that we actually all don't see, we just actually emit rays out of our brains. And then that sort of helped resolve the problem how you visualized, because you were just visualizing this as well. And by the way, the name of the book was Oculus Artificialis. And this particular image was his idea of telepresence, being able to do what I'm doing right now, essentially. If we were to all working remotely and I was sharing my screen, this is sort of his representation of screen sharing. And he also came up with the idea of an aperture camera that didn't manifest for another 100 years. It's kind of interesting. So this is our representation of it today. This is sort of how we think about it. Again, it's just like magnets. We use magnets. We know how magnets work. We do magnetic research all the time. We're pushing the edges of science with magnets. But then at the same time, we have DGNs, deep generator networks, generating images. We have neural networks training on images and being able to recognize images. And that actually ends up doing exactly what Descartes was saying the pineal gland did. And we're able to do that today with a computer. So what we do is we strap someone in an MRI. We train the network on a bunch of images that they look at, and then we show them a new image, and then it synthesizes an image out of this image. So in this particular example, the human has never seen this leopard. And then this is what the computer decides that, or the computer, the network has not been trained on a leopard, I should say. And then the human is shown a leopard, and the network says, well, it's that. So it actually creatively visualizes, it's visualizing at this point. How am I doing? Everybody with me so far? This is weird stuff, I know. So that network, this type of network setup, where it's iterative, where it's generating and testing and running it through the discriminator, is what Facebook is using to take a 2D image and then render a 3D dog out of it. So Facebook, this is an image from Facebook, and they're just, reconstructing essentially the dog's butt and his tail and all that stuff and managing. It's a little blurry, but it looks pretty reasonable. And this was not taken with live or anything. It was just taken from one picture. So they trained a neural network to do this. So it creatively created those extra bits of the frames to do this. So let's talk about where we're at with artificial consciousness today. So this is a semantic map. This is all from NVIDIA. So NVIDIA Research is responsible for all of this work. And if you're interested, this is the URL for this project, which they open sourced. This image that you're seeing that's being uncovered here, this one here, that's not real. It's being generated. It's being generated by a neural network. And it's been generated by a neural network that was trained on the images that were used to reconstruct this. But it broke the parts down. And this is a semantic graph. So this graph has some semantic representation. So for example, you see the pink sidewalk and the purple road, green trees, gray buildings, blue cars. And you have people in here as well. But all of this imagery that you're seeing on this side is all synthesized. It's synthesized using that neural network. So the imagery itself comes out of the network, not out of a bitmap or an image. So in order to achieve this with hardware, here's where we're at today, is we have TPUs. Anybody know what TPUs are? So tensor processing units. This is a Google one. And they're efficient at calculating doing floating point math, which is what you have to use for Tensorflow because you're doing lots of float calculations. But it's not very accurate. So it's kind of like, remember that Intel CPU that came out where it was like sort of off on the floating point math on some times? That's this thing. It's just really fast at doing it, so it's really efficient at generating them. And this is SLAM hardware. So if you guys were in the other session where they were talking about SLAM, SLAM is essentially a way to model 3D. So this is an example of Market Street in San Francisco with some SLAM hardware. And what's interesting about this is the SLAM hardware is actually on a car. And you can see it raising up. So here in a second it's going to repeat, so it's a GIF. And it's going to raise up a little bit before it starts moving. And you can see it sort of elevating itself. And that's all done inside the computer. So the camera, the imagery system is not moving. They're just recalculating what it would look like from the new perspective of the camera. But you can see here you're picking up everything. You see all the people and you see the trees and the buildings. That's not going to pick up imagery or what you would consider like a bitmap. But it's going to pick up the objects itself. So you can imagine shoving all of that data, just replace the human here with that SLAM hardware, and you can train a network on that data. And they're doing that already. That's what NVIDIA did with this. I'm not going to explain TensorFlow. I think most of you know how TensorFlow works. But one thing I would point out, it's kind of like magnets. We are somewhat aware how these layers work, but we're not entirely certain on some networks. Layers, we're not entirely certain about it. So edge detectors, we know sort of kind of how they work because they're fairly simple, But on more complicated models, we don't actually know how, where that data is coming from. We know it works, and we know how to build it, like magnets, but we don't really understand some of the bits that are in here. So I don't want to seem like I should say TensorFlow, we don't know how TensorFlow works. We definitely know how TensorFlow works, but it was an accident itself. Discovery of the TensorFlow processes were an accident. They just kind of stumbled upon it and it was working. So in the case of generating these images, this is sort of how it works. Again, from a real high level. The whole idea here is I'm trying to tell a story across multiple disciplines. So again, I'm not going to go real deep into this. I do understand a lot of this stuff, but I'm not an expert on it by any means. So you have a discriminator. That's just basically the thing. It's a bit like if I said to Steve, hey, does this look like a cat, Steve? And Steve goes, yeah, it looks like a cat. And then I'd show him another picture, and he's like, that doesn't look like a cat. That's essentially a discriminator. And the way that we can run these discriminators, we can train on a bunch of images over here, and then we can then generate a bunch of images or just go get more images. But in this case, we're generating images. And we're basically pitting these two against each other. They're like running a little competition. I'm going to see if I can generate an image to fool the discriminator network. And you have to have a generator, something generate this stuff. And we typically take input noise to do that. So these slides are from Mika at MIT. I got these through the NVIDIA research guys. I couldn't find this online, so I had to go ask. But this is essentially how a neural network sees texture. So you start out with some potatoes, and you end up with various layers of networks. And so some of these are sort of like shape, and some of these are edges, and some of them, maybe this one's the texture one. And then these are just like locations of individual potatoes, maybe. And then what happens is out of each of these layers, you get numbers. You get a statistical fingerprint of each of these layers that you can use. And I think the arrow graphic screwed up here, but essentially you take a randomized image and then you run it back through the network to have it generate it. If you've heard of Deep Dream, then this is how Deep Dream works. And the upshot of all of this is sort of the generalized problem, is that if the statistical outputs of these textures end up, and this is a brick wall, if this is the original brick wall, this is the synthesized brick wall, and if you take this brick wall minus that brick wall, statistically you end up with 0, so therefore they're the same. That's sort of the general approach. And if you take the actual images and subtract them from each other, like just subtract the two image layers from each other, you end up with what looks like a ghost wall. But this is essentially 0. But nevertheless, it allows you to do some interesting things. So again, this is the image, the video that was resynthesized from the original semantic map. So this is a semantic map that was plugged into the computer, and it output this. So again, all of this imagery is coming out of the network itself. And here they just said, well, let's make the trees gray. And what it did is it ended up making all of the trees buildings. So it changed what it was seeing. Changed what you were seeing just by semantically substituting the idea of a building for a tree. All right, building awareness. So she came in and said I had 10 minutes, so that's perfect because this will take about 10 minutes. So I found, machines are not conscious. I mean, I would say they're conscious of some things. So this Boston Dynamics robot, I mean, he's pretty aware of what his objective is. He's going to get through that door, come hell or high water. I mean, like, he could just care less about anything else, right? He's not aware that this guy just ripped his ass off. See that? And he kicks it. See that? I mean, he's not aware of that at all. And that you could say, well, he's not aware of it because he's not looking, or we didn't program that, or whatever. But in general, he's not aware. And so I thought it'd be funny if we got Asmo to have a reaction video. He's like, oh my God, what is he doing to him? So this is a little bit of a harsh jump, but I'm going to jump into semantic awareness, like being aware of something. So a lot of times we think of, when we talk about semantics, we're talking about language. But semantics is also about logic.
the logic of something happening. So here logically Asmo should be reacting this way, because I mean, this guy right here, you know, he's, I don't know, man, he like knocked another robot over with that same hockey stick, a humanoid robot. And he's in general not very nice to these robots, but what does that even mean? The robot doesn't care. So a semantic knowledge would let you care. You would know, hey, I should care about this for the robot. And so I was thinking about, well, how do we do that? Well, we have a way to do that. Today, we have a semantic knowledge graph that we can use to leverage understanding what the relationships are. Just like the NVIDIA guys were saying, you know, these trees and buildings are sort of close to each other. You know, we can sort of interchange the ideas. We can do the exact same thing with a semantic knowledge graph. Semantic knowledge graphs are fairly simple, so they're statistical models. If you had found your way to the Trey Granger's talk, he was actually talking about at the same time I'm talking here. But they return related information about a given corpus. And what I'm going to do is I'm going to jump, in the interest of time, I'm going to jump to this. And so what I did is I indexed, we have a demo of this that you can fire up on Labs. If you go to Lucidworks/Labs. And I indexed physics.stackexchange.com, and I let it run, and I slowed it way down, the crawler, and I let it index about 15 documents. And then I ask it for a semantic result of mind. And if I can get a show of hands, how many people know how semantic knowledge graphs work? Okay, so just a few. So essentially what's happening here, this is a regular, what we would call a regular search index. And this is an inverted index. And essentially what's happening here is, in a regular index, you take the doc and then you look for the terms that you're matching. So I'm searching for mind over here, but let's say I'm searching for software. So then I just run the list and I look for software, and then I return 3 and 1. So I return document 1 and I return document 3, and then I show you the page. That's how search works. An SKG, or semantic knowledge graph, also builds an inverted index. And one way that you can think about semantic knowledge graph, if you know what facets are, counts of things over pages, is sort of like for loops for facets. That's from Eric Hatcher. Gave me that little mind bug. But you have documents. In an inverted index, you have the document IDs and then the position of the word in the document, which means you can start to do distance calculations. So if we were looking at this sign, for example, and we were looking at you, the distance to sponsors would be 2. And if you do that for lots and lots of documents, like we're doing here with physics.stackexchange, which is asking questions and people are providing answers, you get lots and lots of documents with lots and lots of distances and weights between certain types of words. And so you can see what the results were with 15 documents. It returned itself, non, particle, mass, force, low. And I would say particle, mass, and force have nothing to do with mind, but maybe they do, if you're Yoda. But if you let it run for a bit more, you have 415 documents, it changes completely. And you notice that non dropped not much in weight statistically, but it was the only one that managed to make the cut. And keep in mind, this list is really long, and I just chopped it off at somewhere. But I wanted to point out that non managed to stay on the list. And if you do a search on Stack Exchange, you can kind of see why this is true. So here's non-locale, non-locality, mind, non-locality, mind, non-locality. So they're talking about non-locality. And in 2 of these, they're talking about how it's related to mind, and the other one, they're just like, well, keep in mind. So it's different. It's a different topic. So I was thinking, can we leverage semantic statistics to generate images? Because I don't visualize, and maybe a few others of you, I know at least a couple of you in here don't visualize. But could we actually leverage this idea to generate images, like on the fly, as we're walking around listening to things or reading things or crawling websites? One of the things that's interesting about it is that these weights change over time. So the more documents we index and the different types of corpuses that we index, I have 5 minutes. You know, there are changes going on here, and we have floating point weights. So one of the interesting things about Tensorflow is that it's really good at running on floating point numbers. If we can give Tensorflow a floating point number, you can maybe train it, maybe not, though.
but it just depends.
So one of the things that I sort of keep coming back to is like what things are not. And again, we have a thing here, like we know that this, at 15 documents, these were what it was, but at 415 documents, that's what this thing is now not, these things.
So we have a way to, over time, train. And remember, intelligence is linked to being able to reference things back in time like log files. So some intelligence could perhaps come out of it. I'm not claiming anything here. I haven't done this yet. I'm working on doing it. So my objective would be to just simply get the computer to visualize something randomly. So that's actually this thing that we looked at earlier by adding some semantic segments to the generator. In other words, like what NVIDIA did, is give some semantic segments, some subjects, cats, dogs, taxis. I had a friend, I was telling him, I said, I don't know that this talk is going to go very well. It's the first time I've done it. I've practiced it like 4 or 5 times. But whenever I had you guys visualize that taxi, I said to him, I said, don't visualize a taxi, but tell me something related to a taxi. And he goes, I just visualized a taxi. And he said, a road. So he saw the image in his mind, and that image in his mind he used to reference the road, and he pulled the road out, and then he said it. But the way that I did it was I just picked the thing that was on the bottom, which is the tires, or the thing on the top, which would be the light on top of the taxi. So I'm not consciously aware of seeing the taxi. Some of you are not going to be consciously aware of seeing those objects, and you just pull out things differently. But if we're able to sort of get some related stuff to what we're seeing going on in sort of a semantic, logical language layer, we might be able to feed that back in to generate new images. That's just the hypothesis. I have no basis for this, and I have to test it by building it. So I don't really know if it's going to work or not, and I'm not saying to you all that it's something that is true or not. I'm just saying this is how you would go about trying to do this, because there's not a rational way to do it, for sure. So at the end of the crawl of physics.stackexchange.com, I did about 1,600 documents, and I did another term which was called Singularity. I wanted something a little less fluffy than Mind, but a little bit more substantial, that maybe I could get it to visualize. And I ended up with all these terms and these weights. And those are all pretty much related, but again, keep in mind this is physics.stackexchange, and it's a question-answer format. It's not crawling in the entire internet looking for stuff. But then I thought, well, what would be interesting is if I just plugged it back into something that crawled everything, and this is what happened. So I did not plug in Singularity. I plugged in all those other words, and good old Google returned all this. And the reason why, of course, is because Google uses semantic knowledge graphs. They use this to figure it out, and they're also crawling the images and looking at them and stuff. And so even though, you know, I just plugged in Singularity into a small corpus, it returned a bunch of words that made sense to Google enough that they were able to show me a black hole. And I think that this is interesting, but I don't know if it's something that's rational. So that's why I'm just talking about it. And that's it. I appreciate you all for coming. She just opened the door and said stop. So what do y'all think? Any comments, questions? I mean, the questions are going to be kind of strange, but.
Have you started building?
I built the infrastructure for being able to launch all of the different indexes, and I've had like 10 SKG machines spinning at once. So in order to, I could, if I had talked less, I could have done some demos. But if you're interested, I can show you what I'm talking about by spinning up one of these things. But what I kind of did is, so back in the day, I did this thing called Grub. I don't know if anybody's heard of Grub. It's been a long time ago, but it was a distributed web crawler. So it used everybody else's computers to crawl the web. And it was some crazy ass idea I had. And so one of the things that is sort of interesting about this SKG stuff is that if you you know, have small document set, but the information is right, the corpus is right, you actually get kind of weird, scary results because humans are answering the question that you're asking. And Trey Granger does this demo, and he does it for superheroes. And so he asks it, who loves Jean Grey, and it comes back with answers, like Xavier and you know, Wolverine and Cyclops. And the reason why is because you're using a good corpus, but I fired up a whole bunch of these things, and I just queried them, and you get back different answers depending on the corpus and the amount of documents and how the corpus is formed. So I think that's really important here. It's sort of that thing that I was talking about earlier with the brick wall. It's kind of like thinking about the things that aren't what something isn't. The Macy's did a presentation earlier, and they said, this red dress is not what I want to see here. So it's like identifying what things are not, as opposed to what things are. You're not always going to be able to train on what something is, but sometimes you can figure out what things aren't by looking at a certain subset of data. I have a bunch of other stuff, but this is an interesting one. This is from from around 2000. This is from the Egyptian area, Mesopotamian king Tukali, and he's actually has this thing carved. And the way that things work back there with iconography was that he was actually indicating, they know for certain he was indicating that the God in his mind had disappeared, that he no longer heard that God in his mind. So he drew it on a wall, and we have it. And indicating that bicameral mind that I talked about earlier, those audio hallucinations were on the decline. So I sort of speculate that the reason I don't visualize is because that's sort of on the decline, because I have this now. I don't need to visualize. I have this thing with me. And we all use that pretty extensively. So anyway, just a little aside. Any other questions, comments, thoughts? It's a little heavy stuff.
So I'm reading a book right now called The Information, and not very far into the book, they talk about the sort of birth of logic and the Greeks, and how, I don't think he actually backed this up, but he said that before writing, people just sort of talked and everything was a narrative, and they didn't actually formulate things very well, except for like the Iliad, the epics, and things like that. But after writing, they started decomposing what it was what it was they were doing when they were communicating. So they had to come up with logic. And then you have people like Aristotle that they're saying, okay, well, if I'm going to write something down, what exactly am I doing? And then that was the whole birth of those things.
Yep. Zeno of Ella.
Yeah,
we like hung out with Aristotle. So
right,
yeah.
right. So I guess I think it's a pretty, and I was talking to somebody else about this earlier, but I think it's a pretty big leap to say that before writing, we didn't actually think of, you know, we didn't have
Rational thought.
Exactly.
Yeah.
So
yeah.
I don't know if you're implying that text itself could give birth to something that thinks just by manipulating the text, or if there's some other external stuff that has to.
I think it's a holistic thing. So I don't think that we could. I'm not betting on that we can build something that just uses text. I think that what I want to do, like I tried to keep it simple, which is like, what do I lack? I lack the ability to visualize in my mind and re-see things. So in order for me to do it, I have to draw or create a presentation or whatever. I tend to be analytical because of that. But if I could create something that visualizes for me, I could just whisper to it. You know, I could say, hey, do that, and then it visualizes something for me. And then I could say, oh, here are all these related concepts. But all of that is hooked into visual consciousness and hearing consciousness, audio consciousness, and taste consciousness, and body consciousness, and whatever you want to call all those. If you want to say it's okay to split into layers, or it's holistic, it's just your consciousness, which deals with all of these inputs. Either way, it's not just thinking. We definitely have that thinking mind, that, sort of, semantical analysis mind that sort of talks to us, that milk voice. But then some of us can rehear someone talking to us, like our mothers, right? And that's a different voice. That's sort of like audio recall, like hard drive storage recall, whereas this thing is just you talking. You see what I'm saying? So I think it has to be a holistic solution. I think it needs to sort of live in something. That's my personal opinion, and I think it needs to live in something because it needs to be able to have a point of view or a perspective. Like it needs to be able to stand here and look at the room. Now it might be able to scan the room with SLAM and pretend to be back there, but if it's sitting here, it can see stuff. I can see Esther's face from here. From back there, I couldn't. So it wouldn't serve me a lot of use to be back there. So having a presence in this position in space is useful, I think. Seeing, hearing, touching, feeling. Right, having emotional responses. Like I sort of have this wave during my talk. I like kind of get a little nervous, then I go away, and then I go to a new topic, and I'm like, oh crap, I said the wrong thing, and then I get a little wave of nervousness. So that's important too, I think. It's all of that stuff mixing together to get that interesting stuff popping out. You know, like NVIDIA is doing fantastic things. They've built a visual consciousness. Now we just need to add on the other parts, I think.
Well, a lot of the tests that people come up with have to do with relations. Like, you know, the box is inside of another box, inside of another box, and then they try to trick the computer and try to figure out if it's a computer or a person kind of thing. So you use all these relations that you wouldn't get from just analyzing text or analyzing, you know, a definition of a thing. You actually have to have some kind of visualization capability. So,
Right.
Yeah, I think you're right. It's probably a combination.
I mean, I think if we built this hypothetical robot and put it in a cave and sealed it up and maybe gave it a flashlight, it's probably not gonna be able to do a lot, right? And probably do what we would expect it to do, which is not much. But if we put it in there with a bunch of people who are already conscious, it might be able to infer things from that by talking to them and stuff. But I mean, we have to build all the systems for this. We just can't slap stuff together and hope it works. We have to have some rational approach to it. Some of us have to be rational. I look at it, my job is to be rational part of the time and be irrational the other part of the time. So I tried to put that in the preso. I hope it came across like that. But it's a weird topic. I've never talked about anything like this before, so it's definitely interesting. So if any of you have some interesting ideas about this later, then let me know. And if you don't visualize and you didn't know it, come talk to me. Thank you very much. I appreciate y'all.